So, what if the universe has a hidden code? A set of learnable rules that basically govern everything, from how a splash of water works to how entire galaxies form. Today, we're going to dive into this pretty mind-bending idea that AI is right on the verge of cracking that code, and in the process, it's going to completely change how we understand reality itself. Okay, let's just start with a mystery that has scientists and, programmers totally floored. Just try to imagine an AI that can predict how water splashes or how light reflects off a surface, not because someone programmed it with Newton's laws, no, but just by watching videos. Yeah, you heard that right. And that brings us right to our first stop. We're looking at how AI is developing this, well, you could call it intuitive physics. It's like a common sense about the physical world that is both completely surprising and incredibly powerful. And this isn't science fiction, this is happening right now. AI models like Google's VO are creating videos that show this shocking grasp of really complex physics. They can simulate how liquids behave under pressure, the way light glints off a metallic surface, the texture of different materials, and it's all learned just by watching countless hours of video. It's kind of wild. And look, if you want to know just how big a deal this is, you gotta hear from Demis Hassabis, the head of Google DeepMind. He used to be a game developer, so he spent his early career meticulously, painstakingly coding physics engines from scratch. He knows how hard this is. So when he says he's amazed by an AI that can reverse engineer physics from YouTube videos, you know you're looking at something totally new. Okay, so how in the world is this possible? How can an AI just reverse engineer the laws of physics? Well, this leads us to this really profound idea from Hassabis himself, a conjecture that kind of ties this whole thing together. So, when you're giving your Nobel Prize lecture, you go for the big, provocative ideas, right? And that's exactly what Hassabis did. He basically took everything he's learned from building these incredible systems like AlphaGo and AlphaFold and applied it to, well, the universe itself. And here is the core of it, the big idea. The universe isn't just random chaos. From the way a protein folds to the way a galaxy forms, nature has these deep underlying patterns. And the conjecture is that these patterns aren't just there, they are learnable. An AI can actually discover the hidden rules that govern them. And here it is, right here, in his own words. I mean, think about what he's saying. This is a huge statement. It suggests that the same kind of AI that figured out Go or can predict protein structures could, in theory, model almost any process in the natural world. And with the same kinds of computers we have today. Okay, but wait. That just brings up another huge question, right? Why? Why should nature be so convenient? Why should it have this learnable structure in the first place? Well, it turns out it all comes down to a process of selection and stability over just immense periods of time. Think about it. This isn't just biology, survival of the fittest. It applies to everything. A mountain range has the shape it has because it survived millennia of wind and rain. Planets have stable orbits because those were the paths that survived eons of gravitational chaos. Unstable things, they just don't stick around. What we see around us is what has managed to endure, and that very endurance creates a pattern. And this slide really shows you why that matters. It's all about the difference between natural systems and purely abstract problems. Natural systems, they have a history. Their structure has been forged by physical processes, and that leaves behind this trail of breadcrumbs for an AI to follow. But an abstract math problem, like factoring a giant number, well, it doesn't have that history. There's no evolutionary path to learn from, and that's why it's so hard. It might require pure brute force, or maybe even a quantum computer to solve. So, let's follow this thought. If nature really does have a learnable code, what are the implications? This is where it gets really, really interesting. Because if the code exists, then a powerful learning machine is the perfect tool to crack it. This is a completely different way of looking at the universe. Stop thinking of it as just stuff, matter and energy, and start seeing it as a giant informational system. If you do that, everything changes. The laws of physics become the rules of the system, and a powerful AI becomes the ultimate decoder. And this connects to something really deep, one of the biggest unsolved mysteries in all of computer science, the P versus NP problem. So, in simple terms, P problems are easy for computers to solve. NP problems are brutal to solve, but easy to check if you have the answer. The billion-dollar question is, are those hard NP problems just P problems that we haven't figured out how to solve efficiently yet? Well, if the universe itself is an informational system, the answer might not be in a math textbook. It might be written into the fundamental laws of physics.
And the crazy thing is, we're already seeing proof of this. We're seeing it in action. Problems that seemed impossible, with more possibilities than there are atoms in the universe, like protein folding or the game of Go, are now being solved. And why? Because they are natural, structured systems. Their solutions aren't just random noise. They follow a pattern that a neural network can learn.
Okay, so where is all of this headed? What's the end game here? Well, it leads to the ultimate goal for Hassabis and his team at Google DeepMind. The big dream here, the grand vision, isn't just about making a smarter AI to, perform tasks for us. No, it's way bigger than that. The goal is to build AGI to be a partner in science, a tool that can sift through unimaginable amounts of data, spot patterns that we humans would miss, form totally new hypotheses, and help us answer the fundamental questions that we can't solve on our own. And that's really the final takeaway. If we are truly building a machine that can learn the hidden rules of reality, we're not just talking about new tech. This is a whole new era of science. The biggest mysteries of the cosmos, the origin of life, the nature of consciousness, they might finally be on the table. The only question left is, which one do we solve first?